Okay, it's time to start looking at the BSC board. This guy. And as you remember, we were getting just an address bit. And we have three 257s right here. That's 4 bits each. So that would be 12 bits. Well, there's not going to be 12 bits because these only have 9 address bits. So 3 of these aren't going to be used for addressing anyway. And I bet some of them aren't used at all. So if I take my probe, and let's start with this one. And they're always enabled. And that's the select line. So it selects 1, selects 0, 1, 0, 1, 0 over and over. And here's 0, here's 1, and here's its output. I'm just going to go over the outputs. That's an output. That's an output. And what I'm looking for is just crisp signals like that. That looks good. Here's an output and output. Good. Move on to the next chip. Alright. Output. Good. Another output. Looks good. And another output. That looks good. And that don't look good. That's always high. Let's look at the inputs. Here's the remember, it's selecting 1 0 1 0 over and over. So here's the 0 bit, which is low and high. So right there, when it selects 0, it's going to be either low or high depending on where it is in the in the selection. So we should see some toggling anyway. And this is that's the 1 input, so it's always low, but this is our that's the output, and that right there telling, with this being low all the time, with 1 being low all the time, when it selects 1 it should go low, right? But it never does. So that is our bad bit. And I bet you if we looked at the schematic on this, this would be bit 7. That's yeah. Well, let's do it. Let's pull up the schematic for the BSC board and look at, what is it? B4 pin 12. B4 pin 12. So let me grab that and we'll be right back. I bet you that's bit 7. Okay, and here is the buffer system color board. And pin 12 of B4, 4B, pin 12. Right there, see? Boom. 4B pin 12 comes up. Let's follow it. It's right in the middle there, and it comes over to pin 17, which is address bit 7. That is our address bit 7 error. So we'll go ahead, we'll stop, tear it down, and replace that chip, 4B. But before I do that, I'm just going to generally probe around this simple gate stuff and make sure everything looks like it should, and then we'll move on. Okay, I have replaced the 257, and I've oriented the board so that I've slid it over here. This board, these bus headers right here are the exact same headers. So in the upright version with the soundboard, it's like this. It's oriented this way. In the cocktail version, it's oriented with this board over this way, and the soundboard's coming off of these headers up here, these bus headers. Instead, I went ahead and oriented it this way. I'm going to have the soundboards hooked up right here in this empty spot. But for now, we just replaced the 257, so we're going to see what's going on here. And the good news is right off the bat, when I turned it on, without even running the board, I got this. We have something on the screen, which is good. So I want to go ahead and do a RAM short at that color RAM Uh-oh. And now it's giving me every bit bad. What's up with that? Let's do a loop on that. Now it's giving me a different error. It's not that. Huh. I'm going to just do a run. Let's just run the thing. Check our flashes. 1, 2, 3. RAM check. Okay, so what's the next test? Because it did pass this test. See, watch. Let's do it again. Reset. RAM check. Color RAM. RAM check. Pass. Color RAM. No pass. This time it did not pass. Okay, it's still not passing. But it's giving us a, this time it's just giving us flat out a data error. So let's do this again. Let's go RAM short at 8000 to 87FF. Every bit is bad. I'm going to loop it. And we're going to, while that's looping, I'm going to make sure this is hooked up right. It is. It's all good. We're going to come over and grab a 245 out of the 245 pile. Come back over. And we're going to see if this is a problem with this driver. Come on. All right, let's try that again. And read write error, data error. Interesting. Okay, well. Out of curiosity, I'm going to slide this back over and connect to these two headers and see if there might be a bad through hole somewhere or something going on with these two connectors. So I'm just going to eliminate that as an issue. I'll be right back. Okay, so I slid this board back over this way and ran that test, and it passed. The plot thickens. Yeah, interesting. So it's still not, even like this though, it's still not working. So what I want to do is, yeah, see? Let's do a run at and watch the flashes. 1, pass, pass. RAM check. Pass. Pass. Color, yes. So which one was that? 1, 4, 5, 6. Color, pass, pass. Which test is that? You know what I want to do though? I want to sit here and run this thing and probe these. I want to probe all these pins and make sure that nothing's floating or whatever. So let me do that. I'm going to investigate this. I have to be able to hook this up to here. So I'm going to do that really quick. And then we'll be back with, I'll find out which test that was in the manual and we'll go there. Be right back. Okay, after just probing around, I've got it turned off. The 10th pin down from here is floating. It's supposed to be a low. On this one over here, the 10th pin is low all the time. This one, it's floating. So there's a break there somewhere. So I'm going to take this all apart and I want to fix that. And I want to see where it's broke. Okay. It is definitely open from pin 10 over there to pin 10 here. And there's no bottom side trace. It's all top side trace. And if I get on pin 10 from this side, it's good up until right in the middle of the screen there. That middle via. Where the break is right at that corrosion. See that? See the corrosion? I'm going to have to remove this and clean that and make a repair. Yeah, there's corrosion on there and those traces need to be fixed. Yeah, so analyze. Yeah. This side looks okay. This side over here needs to, that one needs to be removed for sure. And that one too, I think. Yeah. Both of these need to be removed. Okay. I'll be right back. Let's do that, fix this up. Okay, and fixed. New headers in there, and you can see where I kind of cleaned it up. Removed any fuzzy. And I did have to run that one jumper on the back. From there down to pin 10. I have not cleaned that yet. But yeah, I did have to run the one jumper. But I beeped it out, and I've beeped out this bus side against this bus side and against this bus side, and they're all good now. So there, fixed that. All right, let's hook back up. Okay. Bad power supply. Bad power supply. I guess I better check the voltage, huh? All right. Now we are reading RAM this way, so that's good. And if we run it, oops, stop. Run, and let's watch our flashes. How many flashes? 1, 2, 3, 4, 5. So the 6th test does not pass. Let's take a look, shall we? Okay. The third test is the screen RAM. That's the third test, or the fourth beep, right? Or the fourth flash. Two, 3, 4, 5, 6. 6 flashes. So the 7th test is what's failing. Three, 4, 5, 6. The 6th test is what's failing. Well, that's confusing. 6th, the ALU intercept circuits on the VFB 1000 board. Okay. I'm going to do it one more time. The test starts on a flash, apparently. Okay, what's going on with this power supply? Alright, I'll be right back. I'm going to test the voltages and find out what's going on with the power supply and all that good stuff. Be right back. Alright, test 6. 6th test here. It says, this is really great. It says the 6th flash plus a tone tests the ALU and the intercept circuits on the VFB 1000 board. Check the ALU chips. I already know they're good. Check the enable gate at 5C, which is a this guy right here is 02. I checked that. It was fine. So I'm checking 12A and 12B, these intercept gates. That's these guys over here, and they're 01s. And I had to actually get my data sheet out. What is a 01? It's an open collector NAND gate, which is configured like an 02. You see how the gates are backwards? They're going towards the front of the chip. Whereas a 00, they go the opposite way. You know, pins 1 and 2 are the inputs, and 3 is the output on a 00. So this is formatted differently. Anywho, I'm on it right here. And this is a 16-pin clip, so it's actually overlapped to the back, so I am actually on the correct pins. And you can see here I have a snapshot. This thing is not working. A NAND, which I got my little notes here. NAND operation is to get a 0, you need 2 1s. You need all 1s to get a 0. And you can see here we've got 0s all the way down through here, even though we have a low up here. Now if this was a high, then every time that this was high you'd get a low. Kind of how it is. But this isn't high all the time. So these shouldn't be here. These low pulses should not be here. So this guy right here, this 01 is not working. This one I looked at and I thought it was looking good. I'm going to take another look at it because I kind of forget. But I thought this one looked okay. But this one's definitely not. So that's a problem. So there's a okay, and alright. After second inspection on this one, it just didn't look right. So I ended up replacing both of these guys. Yeah. So let's go ahead and watch our flashes. We should get our 8 flashes, hopefully. There's 1, 2, 3, 4, 5, 6, 7, and 8. Hey! How about that? Excelente. So now we have this thing running, and it looks like it's running pretty good. I think it actually started off a game. It did. That's not right. So we have coin up issues. We still have problems. It should not have started right into a game. Yeah. So there's even more problems on this board. Goodness gracious. So yeah, with the inputs. So we'll have to look into that. Let's restart it. And it's doing its thing. See that? It goes right into a game. Interesting. Okay. We'll have to look at the input section on this. There's 244s, I know, sample inputs, so